string. Okay, and this. Okay, you get the idea. So if we put bits, let's say number 1, number 2, number 3, number 4, okay, and so on. And let's say that in the beginning the string was straight. Okay, so in the beginning the string looked like this. And it had the same bits. Okay, number 1, number 2, number 3, and so on. I don't want to waste all the lesson, all the lecture drawing the schematics, but you understand. So if we ignore the twisting and bending, and in topology we ignore this. We don't care if it's twisted and bending. It's like in stretching and pulling, it's all okay. So for us in topology, it's the same as a straight line. Okay, so it's like if we were a bug. Okay, a bug is like this small creature that has okay, like if we have a bug, let's say a ladybug, make it red. And the bug has okay, it's a ladybug. And it's walking. Okay, it is walking on the string with the bits, and it checks up the order, which one comes first. First, second, third. For the bug, it will be the same if we put it here, and it will go along the line, and it will see the same order. Okay, first, second, third, and so on. So for the bug, this and this are the same. So in the same way, in topology, for us, the two strings are identical. Okay? So this was figure 1. Okay, so the author tells us that in a similar way, in projective geometry, which is when you see things in a different perspective, okay, it's like if you see a triangle, okay, and it's like hang from the ceiling on a string, on a piece of string, and there is a flashlight here, okay, and it gives light. Okay, this is a flashlight. Make it in more light-like color. Okay, so and it gives, there is a wall here. Okay, there's a wall. Let's say something like this. And on the shadow that this flashlight throws from the triangle, it looks a little different. Like, for example, it would look like this. Okay, for example, this is the shadow. Of this triangle. But we know that it's the shadow of this triangle, okay? So in projective geometry, this triangle is like the same as this one, okay? So in the same way, in topology, we allow certain changes in the shape, like twisting, bending, and so on, and we see it as if it is the same shape. For us, it's the same shape. In topology, we don't care if we bend, twist, and so on. Okay. We do care only if it's continuous, okay, one piece, or not continuous, if it has holes. Okay. Okay, now he says, for example, to allow us to imagine it better, if we can't imagine us being a small bug that corrals on the string, maybe we can imagine the string as the equator, okay? If we have like the Earth, I'm making it in blue because it's the planet, the Earth. Let's say we have, I'm not very good at drawing, but I'm trying. I'm putting Israel in the center because I'm in Israel now, so it's like the logical thing to do. If Israel is here, and you have the Mediterranean and Africa and Arabia and I don't know, India and all Asia and Australia and England somewhere here and America and South America and like I told you, I'm not a painter, but if we take, for example, here we are taking, let's draw it in green. If we take here this point, which is Ecuador. Okay, which is, I'm sorry, which is on the equator. Okay, the equator is this round line that circles all the Earth in the middle. You know, where it's tropical, and for example here Kenya is on the equator, and it causes all the hot places, okay, and humid. And you know the equator, it circles. For example, if the equator goes like this, and in the back, which we don't see, it goes and circles all the way. So if a person, not a bug, but a person walks on the equator, he sees it as if he's walking straight, okay? But he's not walking straight, he's walking in this circle, but it's a very big circle. Okay, so what I'm trying to say is that in topology, it's okay, this is also considered a straight line, okay? Because the order, if we put beads or something, or some map points on this line, it will be in the same order. Okay, if we open the Earth and we take this and make it a line, okay, it will still be in the same order. So it is the same line in the view of topology. Okay, so we will stop now, and the next thing we'll do is figure number 2, which is the turning of a donut into a coffee cup, and we'll see it in a few minutes. Bye bye.